Hello, I'm Rash. I'm a physics major at the University of Texas at Dallas, and I'm excited to share what I did over the summer in Rob Sherko's group here at the MagLab and hopefully convince you why studying creatine is interesting. Creatine is the most researched supplemental performance enhancing drug. It has been shown to be both safe and effective, so much so that you can buy it at Target or GNC. Solid nutraceuticals like creatine are notoriously unregulated. Therefore, efficient strategies are needed to assess these products for impurities, as well as different forms that may be ineffective or even toxic. Furthermore, methods are needed to predict the structures of these solid forms. This will benefit both the manufacturer and the consumer. To accomplish these goals, we focused on three different areas. Ball milling to make our samples, then we characterize our samples first with powder X-ray diffraction and then with solid-state NMR. As part of my REU project, I explored two different forms of creatine, including creatine monohydrate in commercial and lab grade forms and creatine hydrochloride for both a commercial grade product and a form that I made in the lab. First, we acquired the powder X-ray diffraction patterns of creatine monohydrate from GNC in red, Sigma in light blue, and a deuterated version, which we ball milled in the lab in dark blue. Comparison to a simulated PXRD pattern confirms these solid phases are all the same. Then we acquired carbon-13 solid-state NMR spectra of each of these solid forms and found they had similar carbon-13 chemical shifts and showed no signs of impurities. For creatine hydrochloride, we compared the powder X-ray diffraction patterns of the commercial and ball milled samples and found they were in the same phase. However, there is not a known crystal structure, so this gives us an opportunity to use X-ray diffraction and solid-state NMR to work towards determining the structure. First, we indexed these PXOD patterns and found two likely space groups. This gives us some information about the arrangement of atoms in our crystal structure. The carbon-13 solid-state NMR spectra of these two forms were revealing, and that the matching chemical shifts again indicate that they have the same crystalline phase. However, unlike the case for the monohydrate, the hydrochloride salt sample we produce appears to have some impurities that I've highlighted in yellow. Since this is a hydrochloride salt, we can also probe the solid forms using chlorine-35 solid-state NMR. These spectra are really complicated, but really useful for the structural determination and also reveal some presence of sodium chloride indicated near the small peak by the negative 41 parts per million region. In conclusion, multinuclear solid-state NMR is an excellent spectroscopic method for fingerprinting, as well as impurity detection. Moving forward, we would like to incorporate more NMR handles, such as nitrogen-15 for polymorph screening. To predict the crystal structure of creatine hydrochloride, we're using an in-house protocol, and right now we're still exploring both of these avenues. Thank you for listening.